Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 5.2 on solving systems of equations by substitution. Substitution is a name of a method that we use, so you're going to have to remember that. There'll be another method later on in this section. And we're going to use substitution to solve this linear equation. Now, yesterday we looked at solving the systems of equations by graphing. We learned that the point of intersection of the two graphs is the solution for the system. But how can we do that algebraically without graphing? Here's our first method. So here's a little breakdown. What we're going to do. We're going to solve one of the equations for one of the variables. This is very important. We're solving for one of the variables. What does that mean? You got to get one variable by itself on one side of the equal sign. Then we're going to substitute the expression from step one into the other equation and then solve for the other variable. And what does that mean? That's going to be a lot to take in, right? And then substitute the value from step two into one of the other equations and one of the original equations to solve for the missing variable. So we'll go through these steps here. And as I do this, you should make note in your notes as you put these problems into your notebook about what's happening at each of these steps here. Okay? So equation 1, y equals negative 2x minus 9. Equation 2, 6x minus 5y equals negative 19. Now the first step said solve one of the equations for one of the variables. But in this first example, which is an easy one, and I say it's easy because we've already solved for y. Y equals negative 2x minus 9. So what do we mean by substitution? Substitution means that I have a y here and I have a y here. But since this expression is equal to y, I can use that expression in the other equation in place of the y. So I'm going to be writing a third equation, 6x minus 5, not times y, but times negative 2x minus 9. And that's going to be equal to negative 19. So you see what I have here is I have an equation with only x's in it. We can only solve for one variable at a time. So when I have a situation like this with two variables, if x changes, y changes. So there's an infinite number of x's, so there's an infinite number of solutions. Here, well, there's only one variable, so I can go ahead and solve this here. Okay, so I'm going to do the distribution here first. So negative 5 times negative 2x is positive 10x. And then negative 5 times negative 9 is a positive 45. That's equal to negative 19. Okay, so let's simplify here. 6x plus 10x is 16x. Everything else comes down. And then I'll subtract 45 from both sides. Leaving me 16x equals negative 64. Oh, that's easy then. Because then dividing both sides by 16, x will equal negative 4. Right? So I substituted, solved for x, and now I have to solve for y, which means I need to plug this value into one of these original equations. It doesn't matter which one because they're sharing the solution, remember, like we learned yesterday. So I'm going to use the easy one, which is where y is by itself. So y equals negative 2 times x, which is negative 4, minus 9. Okay, so I'm substituting into equation 1. And I'm simplifying negative 2 times negative 4, which is 8. And then 8 minus 9 is negative 1. So my solution here is negative 4, negative 1. Okay. Now, typically, we want to try and check these solutions, but right now, because we're on the video, I don't want to make it too long. But that's our solution here. The next example is a little bit more difficult in that neither of these is solved for a single variable. Remember, solving for a variable would look like I'd have one variable by itself on one side of the equation. So let's go ahead and simplify the first one. I'm going to add x to both sides. So that would make the second one y equals 3 plus x. All right, so since y equals 3 plus x, I can substitute that in for the y in equation 2. So my new equation would be 3x plus 3 plus x equals -1. All right, so let's go ahead and simplify this here. Everything's addition, so I can just basically ignore the parentheses. There's nothing to distribute. So 3x plus x is 4x. And there's nothing to combine with on the other side. So 4x plus 3 equals -1. And subtracting 3 from both sides. (4x) equals -4. Dividing both sides by 4, x equals -1. I still have to substitute back into one of the original equations. I can still use this one because it's really the same equation as this one. I cannot use this one, of course. I have to use one of the original ones. So I'll use this one. So y equals 3 plus x, but in this case x is -1. So 3 plus -1, same as 3 minus 1 is 2. So our solution here, -1, 2. Okay. Now, of course, if you need to go over any of these steps here, you can watch the video again. But the important thing, isolate a variable, solve for a single variable, then substitute to write a third equation that only has one variable in it. Okay? That's the important part. That's the big step. That's the part, that's really the lesson here. Writing that third equation that only has one variable. One variable. Remember that. Because now you can solve. With one variable, you can get a numeric answer to that. Take that answer, substitute back into one of the two original equations, solve for the other variable, and now you have your ordered pair. Okay, that's it. Charmander, I choose you, and I'll see you guys in class. Have a great, great rest of your day. Bye-bye.